Tell me, any question? No. Okay. Okay. So write down circular motion dynamics will do. Note down. Circular motion dynamics. Circular motion, you know, right? Circular motion we have discussed. Kinematics. Kinematics means we study only circular motion. Kinematics study only circular motion. Like particle is there, it is performing circle. Okay, it can be clockwise, anti-clockwise. Correct. Angular speed is there. So suppose particle is going along this circle with constant speed. What you call that circle? What type of motion? Uniform circular motion. So speed is constant. Speed constant, so omega constant. Now what is the relation between speed and omega? V is equal to R omega. Omega is equal to V by R. What is the unit of V? Meter per second. Omega, radian per second. RPM, 1 RPM is equal to pi by 30 radian per second. Okay, you know it already, right? Round per minute. Round per minute. So omega means angle upon time, right? Rate at which angle is covered. Angular speed. This is known as angular speed. So what is the formula for angular speed? Angle upon time. So suppose 1 RPM. 1 RPM. 1 RPM means one round per minute. One round per minute. So what is the angle covered? 2 pi radian. Okay. Divided by time taken 60 seconds. Correct. So you will get this pi by 30 radian per second. Then what is the formula for centripetal acceleration? V square by R. One more formula is there. R omega square. Correct. And R omega is V. So you can write R omega into omega. So you can write V omega also. Correct. V omega. So V square by R. V square by R omega square and V omega. So this is centripetal acceleration. Tangential acceleration, what is the formula? Tangential dv by dt. Correct. It can be written as R alpha. Okay. R alpha. What is alpha? Angular acceleration. Very good. Alpha is angular acceleration. So alpha is angular acceleration, right? So we have discussed this all before. So what is the relation between? Okay, fine. And what is the resultant acceleration? Resultant acceleration square root of AC square plus AT square. Correct. Okay, fine. So this is kinematics. Kinematics means we don't consider y. Okay, like for example, this object is falling down. So I am just observing it is falling down. What is the initial velocity? 0. Okay, so it is going down. It is going down. Speed is increasing. Okay, initial velocity is 0. Speed increasing. Say after some time, speed is v1. I am observing all this. Displacement is s. After time t, displacement is s. So when you observe only speed, time, displacement, velocity, okay, it is kinematics, correct? But What is dynamics? What do you mean by dynamics? What do you mean by dynamics? Dynamics means we study forces. We study forces. Okay, like why motion? Why motion? Okay. So suppose this object is falling. This object is falling. If you study only initial speed, time taken, I have a stopwatch. I am calculating time taken. Okay, speed, distance. So that is kinematics, correct? What is difference between kinematics and dynamics? In kinematics, we study only motion. Like for example, if you talk about circular motion, so this fan is rotating. So I will observe a speed of fan like omega. Okay, initial speed 0. After some time, the speed is 1000 rpm, maybe, correct? So I am observing only speed. So that is kinematics. But why speed is increasing? Why speed is increasing? Why speed is increasing? Why? So why there are changes? So when I start discussing why, are you getting? So that comes in dynamics. Okay, clear? So you can divide physics in two parts: kinematics and dynamics. So note down, if any particle is performing circular motion, note down, any particle, if any particle perform circular motion, if any particle is performing circular motion, force, we study forces acting on it. We study forces acting on it. Like for example, Earth and Moon. Okay, so Earth and Moon, we know that Moon is performing circular motion around Earth. So we know the time also, time period. What is the time period formula? Distance upon speed. You know what is the time period of Moon? After how much time it completes one round? You know time period of Moon? 15 days or 30 days? Around 28 days, 28 point something, correct? So time period of Moon is around 28 days, correct? In 28 days, it completes one round around Earth, one revolution around Earth, correct? Then Earth also rotating. So suppose this is Earth, it is also rotating. So can you tell me what is time period of rotation of Earth? 24 hours, correct? 24 hours, Earth completes one rotation, correct? So that is just observation, time period. Okay, speed, we can find speed also. Okay, if you know the distance, if you know the distance of Moon, it is around 4 lakh, it is around 4 lakh kilometer, 4 lakh kilometer. If you put this radius means distance, and time period we know it is 28 days, so you can calculate the speed also, with what speed Moon is going, correct? So that is kinematics. But why it is performing circular motion around Earth? So why, tell me, why? What is the reason? What force is acting? Gravitational force, correct? So Earth is pulling Moon, so gravitational force. So gravitational force is acting towards Earth, correct? Earth is pulling the Moon towards it. Okay, clear? So Moon is always trying to fall towards Earth. Moon always trying to fall towards Earth, but it has velocity also. So it is not able to fall, and Earth is curved. So suppose if the velocity becomes 0 suddenly, suppose velocity of Moon becomes 0 suddenly, what will happen to Moon? It will come to rest and it will collide with Earth. It will fall like normal object. Are you getting, like how normal this pen is falling towards Earth? Why? Because what is the initial velocity? 0. So it will fall towards earth, correct? If I throw this pen like this, so I am giving velocity like this, so it is not falling here, it is falling there somewhere, correct? So if I throw like this horizontal, if I throw it horizontal, it will fall somewhere there. But if initial velocity is 0, it will fall here, correct? Same thing here. So moon velocity is very fast, it is very fast, very high velocity, okay? So always trying to fall towards earth, but earth is curved, so it is not able to fall. So it is performing circle. And what type of circular motion it is doing? Uniform circular motion, okay? So moon is doing uniform circular motion. So why it is doing circular motion? Because of gravitational force, okay? Because of gravitational force. Similarly, electron also. Electron is revolving around nucleus. What is the charge on nucleus? Charge plus Ze, correct. Z is atomic number, correct? And this is the electron. What is the charge on electron? Minus E. Now this electron is performing circular motion according to Bohr, okay? According to Bohr. So it is performing circular motion. So what force is acting? What force is acting? Electrostatic force of attraction, okay? So this is electrostatic attraction. Nucleus is positively charged, electron is negatively charged, so electron is attracted towards nucleus. But again, electron is not falling towards nucleus. Why? Because it has velocity. It has velocity also. Correct or not? It is very high speed. Electron is very high speed. 2.2. What is the electron speed? 2.2 into 10 raised to 6 meter per second. This is first orbit of hydrogen atom. First orbit of hydrogen atom. What is the speed of electron? 2.2, 10 per 6 meter per second. Okay, clear? Very fast, very high speed. Okay. So electrostatic force is acting here. Gravitational force is acting here. Okay, so this is dynamics. So circular motion dynamics, what you study? What you study? Force, forces. Okay, clear? So note down. So again, what AC is there. So centripetal acceleration. So what is FC? M into AC. So centripetal acceleration. What is the direction of centripetal acceleration? Towards center. So what is centripetal force? Now this is centripetal force. What is the formula for centripetal force? Correct, good. M into AC, and AC formula you know, V square by R, R omega square. Clear? So what is the formula for centripetal force? MV square by R, MR omega square. Clear? So note down. Just note down this formula. We'll do some numericals based on this. So this is known as net force acting towards center. Note down. Net force acting towards center. Net force. Note down. Net force acting towards center. Just remember this point. So suppose this is the mass, particle of mass m. This is the center. Towards center 10 Newton is acting. Away from center 3 Newton is acting. Can you tell me what is the centripetal force? How much centripetal force? Towards center 10 Newton. Away from center 3 Newton. So what is centripetal force? 7 Newton. Very good. So net force towards center is equal to 7 Newton. Okay, 10 minus 3. 10 minus 3 is equal to 7. Okay, clear? So formula is this. This is the formula. Now let's solve some basic numericals. So write down first question. Note down. Now I will give radius in centimeter, okay, mass in gram, and omega in RPM. Clear? You have to calculate centripetal force. Note down, mass is 100 gram. Let's practice some numerical. Mass is 100 gram, radius is 10 centimeter. Omega, so omega is 3000 by pi RPM. Omega. Find centripetal force. FC. Find centripetal force. Centripetal force, you just remember formula mv square by r, mr omega square. What is the meaning? What is the meaning? It is a net force acting towards center. Now you calculate this. Now omega I have given in RPM. So you have to convert this in radian per second. So what is omega? Tell me. First you convert in radian per second. How much? 1 RPM is how much? 1 RPM is pi by 30 radian per second. Very good. Okay. So this is 3000 by pi into pi by 30. So pi cancel. 30 cancel. So how much is omega? 100. 100 radian per second. Okay. Note down. 100 radian per second. So omega is 100 radian per second. Mass, convert mass into kg. 1 gram means 10 raised to minus 3 kg. So this will be 10 raised to minus 1, correct? 10 raised to 2 minus 3. 10 raised to 2 into 10 raised to minus 3. So this will become 10 raised to 2 minus 3. So 10 raised to minus 1. So 0.1 also you can write 0.1. Okay, 10 raised to minus 1 means 1 by 10. So 0.1. Radius, tell me what is the radius? 10 centimeter means now 10 into 10 raised to minus 2. So 10 raised to minus 1. So again 0.1, correct? Okay. Now what is the formula for FC? mr omega square. mr omega square. Clear? So 0.1 into 0.1 into 100 square. 100 square. Now you solve final answer. What is the final answer? So 0.01. 0.1 into 0.1, 0.01. Then 100 square. So 100 into 100. 100 into 0.01, 1. So 1 into 100. So your answer is 100 Newton. Correct? So numericals. First you should understand numericals. Mass will be given in gram, radius centimeter, omega in RPM. Okay. So no unit is SI unit. Correct? What is the SI unit of mass? Kilogram, kg. Radius, what is the SI unit? Meter. Correct? Omega, what is the SI unit? Radian per second. Very good. So, okay, understood. So you should have practice of converting and calculating like this. Okay, clear? Okay, next. Time period I am giving. So, note down. Particle of mass 2 kg perform uniform circular motion with radius 1 meter. It completes 4 rounds in 3 seconds. It completes 4 rounds in 3 seconds. Find centripetal force. Find centripetal force. Okay, now calculate this. How much centripetal force? So mass is given, radius is given, and what is this? What is this? 4 rounds in 3 seconds. What is this? So indirectly they have given omega, correct? 4 rounds in 3 seconds. So omega you can write angle by time. Omega is angle by time, angle by time. Okay, so 3 rounds means what is the angle, total angle? 3 rounds, oh sorry, 4 rounds. 4 rounds of what is the angle? 4 into 2 pi, very good, 4 into 2 pi, very good, and time taken is 3 seconds. So what is omega? 8 by 3 pi, omega is 8 by 3 pi. Okay, clear? Are you getting this? Numericals. So omega is equal to theta by t, angle upon time. So now what is the formula for force? What formula you will use? mr omega square, mr omega square. Okay, mass is 2, radius is 1, omega square. So 8 by 3 pi whole square. So 64 by 9 pi square. 64 by 9 pi square. 128 by 9 pi square. 128 by 9 pi square. Okay. So fine. So this small numericals we are doing, formula based numericals. So sometimes you have to use mv square by r, sometimes you have to use mr omega square. Okay, based on what is given. Clear? Okay. Now let's do some practical examples. Where you see circular motion in our real life. Examples of circular motion in real life. Circular motion in real life. Circular motion in real life. So we have best example, fan, correct? So when I say fan, it is rotation. So fan is doing rotation. So this is the fan. This is the center of the that disc. Okay. So axis. This is known as axis. So axis is passing through center. Okay. This is the axis, and it is rotating like this. So we use rotational motion for fan, but circular motion when you use for a particle. Suppose there is a particle here, anywhere it can be. What is the difference between these two particles, A and B? What is difference? Distance, radius, correct? Radius for A is less, radius for B is more. So understood? So what these particles are doing, if fan is rotating, so these particles are doing what? Circular motion. Are you getting or not? Suppose I move hand like this. So my hand is doing rotation. But if you consider tip of finger, what it is doing? Tip of finger, what it is doing? Circular motion, correct? 5 fingers. So correct or not? Suppose hand is moving like this. So tip of finger, what it is doing? Circular motion, correct or not? It will come down like this. So circular motion. So fan, the tip of blade, you can call it tip of blade. So that is also doing circular motion, correct? So we have one example here. So it is doing circular motion. Tip, any point on the blade. What is the radius for center? Any particle on the center, at the center. Suppose particle is at the center. So what is the radius? 0, very good. And here you have maximum radius. This is maximum radius. Then suppose you are taking a turn. So suppose your car is going and car is coming like this, it is taking a circular turn. Okay. Initially you are going towards north, after some time you are going towards west, correct? So car is taking what? Circular turn. So generally it is circle. Okay, so this is known as circular turn. Car is taking circular turn. Car takes circular turn. Correct? So this is an example of circular motion. It is complete circle or part of circle? In It is part of circle, correct. It is not complete circle. It is part of circle. Maybe quarter circle it is. Suppose you don't want to go to west. You slight angle only. You sometimes you go like this. Okay. So initially you are going north. Now you are going northwest. You are going northwest. Correct or not? So it is not quarter circle. It is less than quarter circle. It is less than quarter circle. Then we have more examples. Speed breaker is there. Suppose this is the speed breaker. So suppose your car is coming like this. This is the car. You are driving your car like this. So speed breakers are generally what type of shape? Circle. Okay. So your car will be here like this. After some time, car is here. Okay. Then car is here. Then car is here. Correct or not? So what type of motion your car is doing? Circular motion. So this is known as speed breaker or speed bump. Okay, speed bump. Sometimes depression is there. Sometimes depression is there. This is known as depression on road. Okay, so this is depression on road. So car is coming like this. Car is coming like this. Okay, then car will enter this depression. So okay, understood like this. So what type of circular motion it is? Horizontal or vertical circular motion? Vertical circular motion. Okay, car is going like this, vertical. This plane is vertical. And when you take a turn, left turn, right turn, so what type of circular motion? Horizontal. So that is horizontal circular motion, correct? So ground is horizontal. Ground is horizontal. So these are some examples. Pendulum is the example. So suppose this is the ceiling and you have connected it with a string. Okay, so you call it a string, and this is the metal ball. So if you hit this metal ball with some speed, so where it will go? It will go a straight line? No. How it will go? Circle. It will follow circle. Okay, understood? It will come to some height, come to rest, then again it will come back. Okay, it will not stop here. It will go to the other side like this. It will go up to here, then again not, then it will stop here, then again come back. So this is pendulum. You call it pendulum. Simple pendulum. Correct. Pendulum and simple pendulum. What is the difference? Simple pendulum, it will not go very far. Okay. Now this is normal pendulum. You can call it pendulum only. This is pendulum because it is going very far. It is going up to here, maybe up to 80 degree. It is making up to 80 degree, correct? So this is pendulum. But simple pendulum is what? Maximum it will go maybe 10 degree, okay, 5 degree, then it will come back like this. So when angle is less, maximum angle is less, we call it simple pendulum, correct? So simple pendulum. So what type of motion it is doing? What type of motion it is doing? Tell me. Circle, correct? It is doing circular motion. It is doing complete circle? No, part of the circle. Very good. Part of the circle. This is to and fro motion. To and fro means coming back also. Going, coming back. Going, coming back. Repeating. Okay, clear? So that is also circular motion only. Okay. Then you have string and ball. String and ball is there. So suppose you have a string. You have any string, anyone? Ball. So suppose this is the ball and this is the string. Okay. Now you have connected ball with a string. Okay. So ball is performing horizontal circular motion. Horizontal circular motion. So that is also circular motion example. So the ball is connected to the string. So string is providing what type of force? String is providing what type of force? Tension. So it will be centripetal force. Correct or not? So is there any earth here? Earth or nucleus? No. So what force is providing centripetal force? Tension. Tension is providing centripetal force. Clear? So these are some examples. Okay. String and ball, pendulum, simple pendulum, depression on road, speed breaker, speed bump. When you take circular turn, so you are in circular motion. Any point on the fan is in circular motion. It can be anti-clockwise, it can be clockwise. Okay. So okay, fine. So let's do some examples one by one. So first you do note down topic string, string and ball, string and ball, string and ball. One ball, one string. In horizontal uniform circular motion. Okay. Now we are studying in detail. Now more depth we are studying. Okay. Examples we have seen. We have discussed just examples. These are just examples. Okay. Fan. One by one. Now we are going to discuss in detail. String and ball. So horizontal circular motion is there. So like this, suppose one ball is here, it is performing circular motion like this. So it is connected to string. So tension, note down, tension will act towards center. This is the center. This will be the center of a string. And some support will be there. So support you can assume table. Suppose there is a table. This is the table. 4 legs are there. Okay. These are the table. Like that table is there. So this is the center. And this is the ball. String. Now it is performing circle. It is performing circle. Correct. So tell me, what is the formula for centripetal force? mv square by r. Now r will be length here. The length of the string is L. Length of the string is L. So radius is L. Radius is equal to L. And that is a centripetal force. And what do you mean by centripetal force? Centripetal force means, what is our meaning? What is the meaning of centripetal force? Net force towards the center. Very good. Net force towards center. And what is the net force towards center here? Tension. Okay. The normal and gravitational force, that is vertical. Normal is vertical, mg is downward. Normal is upward, mg is downward. So normal will be equal to mg. Correct. And tension is the force towards center. So we can equate mv square by L is equal to T. Note down. So tension is equal to mv square by L, or you can say mr omega square also. So tension can also be written as ml omega square. Radius is equal to L. Radius is equal to L. So note down. So ball is there. Suppose there is a ball. It is performing circular motion like this. So string length is L. So here who is providing centripetal force? Tension. So note down. Tension is providing centripetal force. Tension is providing tension is providing centripetal force. Okay, what is centripetal force? It is a net force towards center. Correct? That is general word given, general force, general term. Centripetal force is a general term. Okay, but what is the actual force here? What is the real force here? Tension. So tension is acting as a centripetal force. Okay, so in general, net force towards center is centripetal force. Net force towards center is centripetal force, but here that centripetal force is tension. So tension is providing centripetal force. Okay, ml omega square. ml omega square. So or mv square by r. mv square by r. R means length. Correct? So see, it can be spring also. Suppose a spring is there. The spring constant is k. Now you have connected a block here. Now that block is performing circular motion. So tell me, what is the elongation in the spring? If speed is v and radius is l, tell me what is the elongation? Radius is l, so what is centripetal force? mv square by l. And which force is acting towards center? Spring force. Spring will be elongated. Correct? Suppose you take a spring. Suppose this is the spring. You connect a ball. Now it is rotating like this. It is rotating like this. Horizontal circular motion. Horizontal. This board is horizontal. Okay. So the spring is horizontal. Ball is performing circular motion. The spring will be elongated or compressed. Tell me. It will be elongated. So the spring force will act towards center. Correct? It will be elongated. So spring will pull it. Spring will pull the block. Okay, so this is the spring force. So what is the formula for spring force? Kx. Very good. Kx. Formula for spring force is Kx. So what is the elongation? How much elongation in a spring? mv square by l into k. mv square by l into k. Okay, understood? So before this, what we discussed? String. What is this? This is string. The length of the string is fixed. Length of the string is fixed. Okay, so tension. So just tension is equal to ml omega square, or tension is equal to mv square by l. But here what is there? Spring is there. This is a spring. This is spring. So spring will elongate. Spring will elongate if you connect it with block. So block is performing circular motion, horizontal. Okay, horizontal circular motion. So okay, understood? So kx is acting towards center. Kx, and that kx is providing centripetal force. Okay, so spring force provides centripetal force. So one numerical you write down. So mv square by l is equal to kx. If v is not given, omega is given, then omega formula you have to use. Suppose omega is given, omega. So what you write? ml omega square is equal to kx. ml omega square is equal to kx. Okay, clear? So solve this question. Block of mass 1 kg attached to spring of spring constant 100 Newton per meter. Okay, spring constant means k. So k value I am giving. Okay, remember spring constant. If soft spring is there, spring constant is more or less. Soft spring means k is less. If hard spring is there, difficult to compress, so k is more. Correct? Like suppose one spring is like this and another spring is like this. Which spring is easy to, which spring has more K value? K value is inversely proportional to natural length, correct? This natural length less, this natural length more. More natural length means K less, less K, and this is more K, correct? Spring is small, so K is more. We have discussed this, okay? Spring is small, K is more. It is difficult to elongate. So soft spring means K is less, hard spring means K is more. So spring constant, okay? Spring constant is 100 Newton per meter, okay? Now radius is given, radius of circular motion is 2 meter, radius of circular motion 2 meter, mass I have given, radius I have given. If tangential velocity is 2 meter per second, find elongation in a spring. Find elongation. Okay, calculate. Find elongation in a spring. So there is a spring here. Okay, spring is there. It is performing rotational motion. Particle is performing circular motion. Particle is performing circular motion. So use the formula mv square by r is equal to kx. Use this. Tell me what is the answer. So kx is equal to mv square by l. What is the length? What is radius? Radius is given. Okay, clear? This question. Spring is there. This is the spring. This is a fixed end. This is the fixed end. Other end you have connected a block. Block is performing circular motion. What type of circular motion? Uniform circular motion. So what is the formula for spring force? Spring force, what is the formula? Kx. Spring force is equal to Kx. And the centripetal force is spring force. So centripetal force is mv square by l. Okay, so mv square by l is equal to Kx. mv square by l is equal to Kx. So what is x? mv square by l into K. So L means radius. So mass is 1. What speed it is going? 2. So 2 square. And radius is 2 meter. Radius is 2 meter. And K value is 100. K value is 100. 100 Newton per meter. So 2 by 100. Okay, 2 square by 2. Okay, clear? 2 by 100. 2 by 100 meter. So 2 centimeter, correct? Four by two into 100. So this is 2 by 100. So 2 by 100 means 2 centimeter. Okay, 2 by 100 meter. 2 by 100 meter or 2 centimeter. Are you getting or not? Okay. 1 meter means 100 centimeter. 1 meter is 100 centimeter. Okay, done. So this is one string and one ball. What if I connect 2 strings and 2 balls like this? One string, one ball, another string, another ball. Suppose this is M1, this is M2, and this is the center. This is the center. Now how will you solve this? So This is the center. This is string 1, and this is string 2. Okay, string 1, string 2. Now, what is the radius of M1? Radius of M1, suppose L1. Radius of M1 is L1. And what is the radius for M2? L1 plus L2. Very good. So note down two balls of mass M1 and M2. Two balls of mass M1 and M2 perform uniform circular motion. Uniform circular motion. Okay, note down. Previous question clear, everyone? Any doubt? Kx is equal to mv square by L. Okay, Kx. Spring force is equal to mv square by L. Okay, Kx. So x is equal to mv square by Lk. Now come to next question. Previously, before one ball, one string. Now two balls, two string. Now they are performing circular motion. This M1 is performing circular motion with what radius? L1. M2 greater radius. Okay, greater radius. What is the radius? L1 plus L2. Very good. Now string is there. This is the string. So string always pulls. Okay. So this string will pull M1 with what force? Tension force T1. Now this is tension force T1. And string 2 will pull M1 with what force? Tension force T2. Are you getting? String always pulls. Remember, string pull or push? String pull. Suppose this is the string. Ball is here. Ball is performing circular motion. So this string is holding it. Okay. So it is pulling it here. Now this string is holding M2. So what is the direction of tension or M2? Towards center. Okay, clear? Now you tell me which is greater, T1 or T2? Which is greater? This M1 is performing circular motion of radius L1. Okay, M1 is performing circular motion of radius L1. M2 is performing circular motion of radius L1 plus L2. So what is the direction of net force? Net force is in which direction? In uniform circular motion. In uniform circular motion, net force is towards center. Net force is towards center. Okay. So let's take angular speed is omega. You draw like this. Angular speed is omega. So net force is towards center. So which is greater force, T1 or T2? T1. T1 is greater. T1 is acting towards center for M1. T2 is acting away from center. Are you getting? String pulls. Okay. This is one string. This is second string. String 1 is pulling M1 here. String 2 is pulling M2 here. M1 here, and pulling M2 here, like left. String pulls. Remember. Okay. So what is for M1? What is the net force? Tell me. For M1, what is the net force? Difference, T1 minus T2. So this is the net force. So net force towards center. And what is the formula for net force towards center? M R omega square, mr omega square. Omega is given. Okay, omega is given. So tell me, what is T1 minus T2? Mr omega square. What is R here? L1. Mass here? M1. So M1 L1 omega square. Are you getting? Suppose T1 is 10 Newton. I'm just giving one example. Suppose T1 is 10 Newton, T2 is 8 Newton. So what is the net force towards center? 10 minus 8. 2. Okay, 2 Newton. Similarly, you write for M2. For M2, what you write? What is the net force towards center? T2. Is there any force right side? No. So only one force is there. So for note down, for M2, T2. T2 is the unbalanced force. Unbalanced force. So what is the formula for net force towards center? Mr omega square. Mr omega. So what is the mass of T2? M2. Radius for L1 plus L2. Correct. Radius is L1 plus L2. Omega is same. Omega is same for both. Okay, clear? Why omega is same, I will tell. First you write down this T1 minus T2 is M1 L1 omega square, and T2 is M2 L1 plus L2 omega square. Omega, what do you mean by omega? Angle upon time. Omega is equal to angle by time. Suppose one ball is here, another ball is here, and this is the center. This is the center. This ball is connected to the center with a string, and this ball is also connected to this ball with a string. When this ball is here, this ball will be here. Correct? So what angle it is making? Suppose theta. So what is the angle covered by ball 1? Angle covered by ball 1? Theta. What is angle covered by ball 2? Theta. Angle is same. Okay, angle is same. Time taken is also same. Here to here time is t. So here to here time is also t. What is different? What is different for both? Linear speed. So linear speed is different. Linear speed v1 and v2. So tell me, what is v1? Suppose radius is r1 and for 2 radius is r2. So what is v1? r1 into omega. Very good. And what is v2? r2 omega. r2, radius directly r2. Here r2 is L1 plus L2. What is the radius for second particle? Radius. This is radius r2 and this is radius r1. So r1 is equal to L1 and r2 is equal to L1 plus L2. I think I have drawn big circle. Okay, I will, no problem. I can make it a small circle. So now you observe. This is the radius for M1. This is the radius for M2. So omega is same. Omega is same for both. Now you solve this. Find T1. T2 you got. This is T2. T2 is M2 L1 plus L2 bracket close into omega square. Now what is T1? Now solve for T1. So put T2 here. Okay, so T1 I am writing. So T1 is equal to, note down. So T1 is equal to T2 plus M1 L1 omega square, and T2 is this. So M2 into L1 plus L2 omega square plus M1 L1 omega square. Okay, so this is T1. T1. So what is the basic concept? If in whole this chapter you just remember net force towards center, net force towards center is centripetal force. What is the formula for centripetal force? Mr omega square. Okay, then how to find net force towards center, that you have learned in Newton's laws. Okay, Newton's first law, second law, third law. Okay, laws of motion. How to calculate net force we have discussed in laws of motion. Just equate it with mr omega square. Okay, done. So T2 is this m2 L1 plus L2 omega square. T1 is T2 plus m1 L1 omega square. So now you solve this question now. Suppose these are the two balls, mass is m and 2m, masses this is string 1, string 2, length of string 1 is L, length of string 2 is also L, length of string 2 is also L. So for M, T1 will act towards center, this is the center, T2 will act away from center. So this string is pulling M here, and the same string will pull to a left. Okay, so tell me what you write for M, what you write? Ball A, you can call it ball A, this is ball B. For A, what you write? Ball A, what you write? Tell me what is the force towards center? T1 is towards center, T2 is away from center. So what is the net force? T1 minus T2 is equal to, net force is equal to mr omega square. So mr, what is r? L omega square. Understood? Okay, for B what you write? Tell me. For B, so ball B, tell me what is the force towards center? T2. So T2 is equal to m 2m, radius 2l omega square. Very good. Now find T1 and T2. So T2 is 4 ml omega square, correct? T2. And now calculate T1. Calculate T1. So T1 is equal to T2 plus ml omega square, and T2 is 4 ml. Okay, 2 into 2, 4. So what is the answer? 5. Good. So 4 ml is omega square plus ml omega square. So 4 plus 1. So 5 ml omega square. 5 ml omega square. Okay, so what is the ratio? T1 by T2, what is the ratio? T1 by T2. T1 is 5 and T2 is 4 ml omega square. Understood? Ml omega square, ml is omega square cancel. So 5 by 4. T1 by T2 is 5 by 4. Okay, clear? So this is how you calculate. Okay, clear? Fine. Any doubt? So how many balls? 2 balls. How many strings? 2 strings. Okay, clear? Now I will give 3 strings. Same method. Use the same method. 1 string, 1 ball. Second string, second ball. Third string, third ball. Masses M, 2M, 3M. Now length of first string L, length of second string L, length of third string L. Now calculate. Now first string tension T1. So for ball A, okay, this is ball A, ball B, ball C. So T2 will act right side, away from center, right? This is center. For 2M, what force will act towards center? T2. This is a string, okay? This is string 2, string 1. This is string 1. This is string 2. This is string 3. So now you say for string 3 will pull 2M right side. So this is what force? T3. And the same string 3 will pull 3M left side. Understood? So what is the net force on A? Net force on A, tell me. It is very easy. Just how you solve previous question. T1 minus T2. Very good. So you will write T1 minus T2 is equal to mR omega square. What is R for this? L. Mass M. So mR omega square. Okay. Now what you write for second ball? What is the net force? T2 minus T3. Very good. T2 minus T3 is equal to 2M. What is the radius? 2L omega square. Correct. Good. Now for third what you write? T3 is equal to 3M 3L into omega square. Correct. Very good. So now you solve this. So T3 is equal to 3 into 3, 9. So this is 9 ml omega square. Correct. Now calculate T2. How to find T2? T2 will be T3 plus 4 ml omega square. T3 is this 9 ml omega square. So what is T2? 13 ml omega square. Now you got T2. Now find T1. Find T1. T1 is equal to, correct, T2 plus ml omega square, and T2 you got. T2 is this. So 13 ml omega square plus ml omega square. So 14 ml omega square. Okay, clear? T1 is 14 ml omega square. Are you getting? Okay, clear. Good. So more effort, more calculation. Okay. Two strings, easiest. What was the easiest? One string, one ball. Then more calculation. Two string, two balls. Now more calculation. Three strings, three balls. Enough. Three string, okay. Four string I am not giving. Okay. So just remember, net force is MA. Net force is MA. Net force is MA. Net force is MA. So A is R omega square or V square by R. So centripetal force is equal to mv square by r or mr omega square. So these type of questions, omega you have to take, omega. So T1, T2, T3. String 1 tension is T1, string 2 tension is T2, string 3 tension is T3. So for ball 1, T1 minus T2. For ball 2, T2 minus T3. For ball C, T3. Okay, these are the equations. So that is string and ball. string and ball. In horizontal, what type of circular motion? Horizontal. Horizontal circular motion. And uniform or non-uniform? Uniform. Uniform. Now there is a question. Suppose this is the table. This is a table, like that table is there, and there is a hole here. A small hole is there. Okay, and it is a smooth table. This table is a smooth. What type of table? Horizontal. Horizontal table is there. Hole is there. Now one block is there. Mass of the block is m1. One string is connecting m1 and passing through the hole. Now, okay, string is there. Now it is coming down here through the hole. And another block of mass m2 is hanging. Another block of mass m2 is hanging. Now I don't want m2 to fall. So what is the force downward? m2g. Now I don't want to fall it. So tension must be acting upward. So what should be tension? Suppose it is not falling down, it is at rest. What is tension? m2g. Very good. So tension is equal to m2g. Now it is the same string. It is the same string. Okay, this is the table. It is the same string. So here also same tension will be there. Same tension here. So what type of this portion of the string is horizontal and this portion is vertical. Now in order to keep it at rest, tension should be there. So this block should rotate. Okay, this block should perform circular motion, uniform circular motion. Note down. So it is performing circular motion. This block is performing circular motion. Now radius of that circular motion is r. This radius is r. So note down. M1 kept on table, smooth table. M1 kept on smooth table is doing uniform circular motion of radius of what radius? R. M1 is doing uniform circular motion with radius R, angular speed omega. Angular speed omega. Now you tell me what is tension here. Tell me what is tension. How much tension? Tell me tension. M R M1. Tension is mg, correct, and tension is m2g for this. And for this, what is tension? M1 R omega square. Correct, good. Now this tension and this tension both are same because the string is same. So note down. Same string connects two blocks. Okay, so this part is horizontal, this part is vertical. Okay, it is like this. It is like this. Horizontal, vertical. This length of horizontal part is r. Length of horizontal part this is r. So tension is m2g, here also tension is m1 r omega square. So both tensions are same only. So you will write m1 r omega square is equal to m2g. M2g. Okay, clear? Okay, done. Okay, fine. If you want to note down, you can note down. M1 kept on a smooth table is doing uniform circular motion of radius r, angular speed omega. Okay, there is a hole in the table. Note down this also, you write down. There is small hole in table, small hole in table. Same string connects two blocks, M1, M2. Same string connects two blocks. This came in NEET also. I think 2021 one NEET question was there. Okay, this question came. So just one formula was there in that question. Okay, understood. So M1 R omega square is equal to M2G. Okay, I will show you the exact question. So okay, we'll see it in your MTG book is there. Okay, you will find the same question you will find in MTG. Okay, check it. Then I'm giving some more questions. You just write down some 4 to 5 questions I'm writing on the board. You just copy it. Particle of mass m tied to tied to tied to means connected to tied to string of length L. World in circle, world into horizontal plane. World means like this, it is rotating. World means rotating. Okay, I have one wire. Tomorrow you bring one ball and string. Okay, this is known as whirl. This is known as whirl. Okay, like this. This is whirl. So whirl means horizontal plane. Rotating. You can make anything ball. You know, you take a small cloth, take a thread, and it will become ball. Okay, and one string is there. Okay, tomorrow you bring, huh? Bring it. Okay, who will bring? Who? Tell me. Huh? What? Pen. But I need thread also. Thread also. Thread. Huh? You have? Okay. After break you arrange. Okay. So note down. Complete the question. World in horizontal plane. If tension is T, find its linear speed. Find its linear speed V. Find its linear speed. These are options. Square root TL by M, square root 2TL by M, square root 3TL by M, square root T by ML. Okay, note down. In above question, if initial angular speed is 10 rpm, now tension is quadrupled. Tension is quadrupled. Quadruple means 4 times. Double means 2 times. Triple means 3 times. Quadrupled means 4 times. Keeping radius same. Keeping same radius. Find new angular speed. Find new angular speed. (20 rpm, 40 rpm, 5 rpm, 10 rpm. Last question. Two stones of masses m and 2m whirled whirled in horizontal circular motion. Heavier stone radius r by 2, lighter stone radius r. Lighter stone radius r. If tangential speed, you just copy the question first. After break, you can solve. Tangential speed of lighter stone. Tangential speed of lighter stone is n times heavier stone. N times that of heavier stone. If same centripetal force, if both experience same centripetal force, find n. If both experience same centripetal force, find n. This question came in 2015. Okay. This question is a 2024. This question came in 2024. Okay, just copy the question, take break now, so we'll continue.